So when looking at the last section with the fundamental counting principle, what we were looking at was multiplying numbers at times, like we did one with 5 times 4 times 3 times 2 times 1. Well, that's not too bad, but when we get to situations where we have to multiply, say, 20 arrangements with no repetition, or 30 arrangements, so 20 times 19 times 18 times 17 times 16 times 15 times 14, that can get a little tedious. So there is a mathematical notation and button on scientific and graphing calculators that will allow you to do it, and that is the factorial button. So factorial means that we're going to multiply whatever our number is. So if I say 5 factorial, that means I'm going to multiply 5 times 4 times 3 times 2 times 1. 6 factorial with 6 times 5 times 4 times 3 times 2 times 1. And so we're multiplying that number and every subsequent whole number down to 1. And so it's noted in mathematics as an exclamation mark. So this here reads n factorial. So if I had 5 factorial, like we had, which is similar to what we would have done before in that last section, because we had 5 times 4 times 3 times 2 times 1, well, 5 factorial is equal to 120. And so you should be able to find this button on your calculator. Oftentimes it is accessed using the shift or second function key, depending on your calculator brand. If you get the calculator app and you get one of these fancy dancy TI-83 Plus emulators on this calculator here, what I would do is I would type in 5, and then I'm going to go to the math functions, and then under PRB for probability, you'll see the different probability functions, and it's number 4 here. And so I'll hit enter on number 4. 5 factorial, you can see there, and then I get, again, 120. So we use this a lot in this class, so become familiar with that button. There's another couple buttons that I'll show you that'll allow you to do some of these work with factorials in the coming units and in this next section. So in the case of this next question here, we have 10 factorial divided by 5 factorial. So there's a couple ways to do this. You could do 10 factorial divided by 5 factorial with the calculator, or if we illustrate this, what we have is 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 factorial. And I'm going to stop there, and I'll show you why in a moment. When I finish that and put the 5 factorial in the bottom, well, 5 factorial and 5 factorial, those will factor out. And so I'm left with a 1 on the bottom and a 1 here. So I have 10 times 9 times 8 times 7 times 6. So there are situations where we can factor out the factorials, and that will be useful when we're doing some of our calculations at times. So here we have just 10 times 9 times 8 times 7 times 6. So we only have that series of 5. So I can do that without too much trouble using my calculator and get my answer of 30,240. Okay, or again, I could type in those factorials using the factorial button on my calculator. Some calculators, when we get to really big numbers, can only handle certain factorials before they give you an error. So there are times when we work with really large numbers, but we'll be having that division by a really large number at the same time, and that'll fix it up. So my calculator, I just tried 99 factorial on this graphing calculator that has a good memory block in it, and it had an overflow error, so it wasn't able to even handle 99 factorial. So there'll be cases where we might have 300 factorial divided by 297 factorial. Your calculator won't be able to handle the 300 factorial, so this method here will work though. 300 times 299 times 298 might be a lot easier. Okay, so moving on. So now a more direct focus with permutations. So the whole unit's about permutations, and we've been generally looking at permutations, but we're going to do a little more focused look at it. So as a definition, it's just an arrangement of items in a specific order. So order does matter, and this is going to be the concept that'll help us define permutations from combinations, which you see in the next unit. Order does matter. And so formulaically, in general, the number of permutations, the equation or the notation looks like this. It also could look like this. There's, depending on, this is more of a classical notation. This is more of a modern notation. You'll usually see that with calculators, it written like this. All this means is how many ways can we, if we have n items and we select n of them, what are the number of permutations that are there? How many arrangements of them are there if order matters? It's just n factorial, so it's n times n minus 1 times n minus 2, all the way down to 3 times 2 times 1. Okay, so this is just basically the permutation notation for factorial. So if we have the example here, how many numbers can be made with the digits 1, 2, 3, 4, 5, 6, 7 if each is only used once? Well, we have 7 digits, so we're doing 7 permutations of or 7 items, and we're selecting 7 of them for the so how many permutations are there? So this is equal to 7 factorial. And again, we can do 7 times 6 times 5 times 4 times 3 times 2 times 1 in our calculator, or use the permutation, or sorry, the factorial button, which I'm going to do here, and get an answer of 5,040. So 7 factorial is 5,040. For each digit is only used once. So how many ways are we arranging those? Using, again, each digit once. And that was important in this case here, that we use the factorial notation. All right, so the next page. We have the situation now where that was if we have used all 7 items. And now more apt, more useful of a permutation is that, and generalizes, we have the some items are selected, but this same generalized formula on your calculator, because this function is generally on most calculators, will work if you use all the items as well. So we have n permutations, or n items, and how many permutations with r selected. So this is the total items. This is the number used. And so what happens is this then requires some division. And this is like example B in that initial calculate question we did. So it's this with factorials translates to n factorial over n minus r factorial. So the total number of items, as if we were arranging everything, divided by n minus r. So the total minus the number of arrangements that we have. So the number of places that we're not using is what this works out to. And it works out step by step. That's the mathematics to it. But in general, you'll be able to use this button on a calculator, and I'll show that in some of these examples. So if we have 8 runners in a race, how many ways can the first, second, and third place medals be awarded? So we'll look at a few methods of doing that. So again, we have first, second, and third place. So order matters, right? We have first place, second place, and third place in a race. How many ways can we arrange these? Well, we have 8 people that could possibly come in first. But once we pick the first place person, we have 7 people that could come in first. And then we have 6 people that can come in third. Sorry, 8 people in first, 7 people in second, and then 6 people in third. So 8 times 7 times 6 would get us a result. So 8 times 7 times 6 is going to give us 336 different possibilities. Now, if we use our permutation formula here, we would have 8 and then 8p and 3. Okay, so we have 8 total racers. We're selecting 3 of them for our permutation, and so as a factorial notation, that's going to be 8 factorial over 8 minus 3 factorial. Sorry, 8 minus 3 in brackets and then the factorial sign. And then that is 8 factorial over 5 factorial, which is 8 times 7 times 6 times 5 factorial over 5 factorial. The 5's cancel. And again, we have the 8 times 7 times 6, which we already figured out was 336. Now, with your calculator out there, what you can do is, depending on your calculator, how it works, some you may press the 8 first. And I'm just recalling this right now. So you press, in my calculator, I press 8 first. And then there's my NPR. And then I'm going to have 3. And there's my 336. Again, this depends on your calculator. Some calculators might require you to press the NPR button and then use the parenthesis method, like this. So it might have, you might press that button and then you have to put the first number, comma, the next number. But in most modern calculators, you should be just pressing the first, the total number of items, and then the NPR, and then the number of items you want to select out of that group. Okay, so most calculators, scientific calculators, should have that. Again, it will probably be a shift or second function button to access that. Unless you have a fancy Nancy graphic calculator, then you might have the option of doing that with a more complicated mode, like I do. All right, we're going to try another question here using the same concepts. So we have 10 people lining up for a photo. And now in this case, we have a photographer wanting to keep the 2 siblings in the group together. So there's 10 people, but there's a pair of siblings in that group. They want to stay together. How many ways can they all line up? So in this case, what we do is we have to look at that order. So this is a permutation, is the restriction of keeping those 2 together. So we'll look at it a couple different ways. If we look at it using the spaces, we have 10 people, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 arrangements of people, but we're keeping a pair together. So if we keep them together, we can treat them as one item. And so we only have 9 spaces to arrange them in. And then we're going to have a pair of siblings together. So we have not 10 people, we'll have 9 positions to fill if we treat those 2 people together as one. So we could have 9, 8, 7, 6, 5, 4, 3, 2, 1. And then we'd multiply all of these together. Now, also, what's happening is with those 2 people, they can be arranged in 2 ways. So we can put those 2 people, so those 2 people can be arranged in one of 2 ways. They can either be, the older sibling, then the younger sibling, or the younger sibling, the older sibling. So then we would also multiply this whole thing by 2 to arrange that pair of people. So 9 factorial times 2 is what we have here, and 9 factorial times 2 is going to give us 725,760. So that's one way of doing it. The other way is, so that's the way of doing it. And then if we wrote this out as a factorial formally, this is 9 factorial for the arrangement of keeping that pair together, considering that pair is one group. So we have 9 factorial, and then we're multiplying that. And the 2, we had 2 people we were arranging, so realistically this is 2 factorial. And that's important because if we had, say, 3 siblings that we were keeping together, there would be 3 factorial ways of arranging them. 2 factorial, we already calculated this was 9 factorial, and then 2 factorial is 2 times 1, or just 2. So that is the same thing. So simplistically, this is group those items that need to stay together, treat them as one thing. So that's what we did. We treated them as one block. Say they happen to be this one. So there's our one block, those 2 guys. And then the other positions were treated as individuals. And then we were able to multiply that by the change. So a little bit of practice with that, you should be able to understand that more, this is where it's important to make sure you're reading these questions and understanding the different situations. And as we move forward, make sure you're really getting that every case that we're working with the situation that order does matter. So we're just filling in those positions. And again, we have a couple options for doing the calculations. I traditionally would go to these spaces to visualize it for me. So I draw out my spaces and see who fills them in. Then formulaically, it is just 8 P3 here. And then here, again, in this type of situation, I again fill in those spaces. This allowed me to visualize. Okay, I'm putting them all out here, but that one option is going to have the 2 factorial. So it takes a little bit of work sometimes to wrap your head around. It's a different type of thinking, but a little practice, you should be fine.